Now suppose I'm given the graph of a line, and I don't know, maybe it's this line here. Maybe it goes through 2, 3, and I'm making this up, 4, 7. Okay, what is the slope here? Well, just remember that your slope is your rise over your run. So your rise is how far you go for a certain run. So here, let's look at what the run is. The run is what? Well, if I start at 2 and end up at 4, my run is 4 minus 2, isn't it? So it's 2. What's my rise? Well, I start at 3 and I move to 7, so my rise is 7 minus 3. It's 4. So that means if I go forward by 2, I go up by 4. Okay? So maybe let's write that here. Forward by 2. So that means a run of 2. Rise by 4. Now my slope is when I go forward by 1. Forward by 1. So if I go forward by 1, I just need to change that 4 here by dividing it by the 2 I have here. So 4 by 1, I will actually take my rise and divide it by my run, right? 4 divided by 2. That's going to give me by how much up I go if I go forward by 1, right? Because if I go forward by 2, I go up by 4. So if instead I go forward by 1, this will be 2 now, because those triangles are proportional, right? So if you shrink this guy by 2, you have to shrink that guy by 2 as well. Okay, so if you end up with some run here, with some number and some rise, and you want to go know how much up you go if you go forward by 1, you have to divide your rise by your run. So this is why we say the slope is rise over run. And what's the rise is, I say rise, but it can actually go down. It's going to be the change in y. Here we were going up, but if I have a line like this, we'd be going down. So this is why I'm going to talk about the change in y, and the run is the change in x. Often we write this as delta y, change in y. Delta x is the change in x. So if I have, just on purpose, I'll choose a line that goes down. If I've got a point here, let's say with coordinates x1, y1, and this one is a point with coordinates x2, y2, how do I calculate my slope? Well, I can calculate my run. Run here is x2 minus x1. So typically we take the largest x coordinate, subtract the smallest x coordinate to get the run. And for the rise, we essentially subtract in the same way the y coordinates, so y2 minus y1. So here my rise would be something negative. That's because I'm going down. So here, my delta y, that's exactly what my delta x is here. This is my delta y. So it's y2, typically we write it as y2 minus y1 over x2 minus x1. Okay, so in our example here, okay, the slope, which would be y2 minus y1 over x2 minus x1, typically I recommend here at the bottom starting with the highest x value. What's our x value? It's x minus 2. And then you have to match here, this y here has to match that 4. So the 4 here goes with the 7. So this has to be 7. You can't use 3. So 7 minus 3. So we get 4 divided by 2. We get 2 as expected. So this is what our slope is. Okay, but notice that, let's say instead, I actually choose for x2, I choose the 2 here. Let's say I do 2. So of course, what goes with the y that goes with the 2 is the 3 here. So if I subtract instead 2 with 4 like that, and 3 with 7, what am I going to get? I'm going to get minus 4 here and minus 2, but after simplifying, that's still 2. So in fact, it doesn't matter in which order I choose my points, okay? So I told you here, typically choose x2 to be larger than x1. That's because you're going to end up with a positive here. But if you don't, you're going to end up with a negative. But that's okay. At the top, the sign of the subtraction of the y coordinates will change as well. So in fact, that's because here I can say this is also the same as y1 minus y2 over x1 minus x2. So if I switch the order of the subtraction at the top and at the bottom at the same time, it's not changing the value of the fraction. That's because this, I can rewrite it by factoring out a minus sign. And if I do, you see I'm going to get minus y2 plus y1. And if I do the same here, factor out the minus sign, I'm going to get minus x2 plus x1. And after canceling those two, which are two negatives, right? Look what I get when I'm left with inside my brackets. I'm left with the expression y1 here, y1 minus y2, and here x1 minus x2, which is exactly this. So that's why if you choose the points in a different order, right, the slope is still the same. So that formula works no matter what. It's just that if your x and y coordinates that you choose at first, they have to match. Okay, it can't be an x coordinate from one point and a y coordinate from another point.